Okay, today we're going to learn about graphing secant and cosecant graphs. And if you can graph sine and cosine, you can graph secant and cosecant. They're pretty simple. It basically you're graphing sine and cosine, and then you're doing the reciprocal identities. So that's your key idea, that we call your reciprocal identities that cosecant of x is equal to 1 over sine of x, and secant of x is equal to 1 over cosine of x. And so what we're going to do, anytime we're asked to graph the cosecant graph, we're first going to graph the sine graph. And then we're going to do 1 over each of our points, our values. So if I'm asked to graph 1 over if I'm asked to graph y equals cosecant of x, I'm first going to graph y equals sine of x. So that's pi over 2 pi, 3 pi over 2, and 2 pi. I'm labeling my axes. Well, I said from 0 to 2 pi, so I only need the left end point here. All right, so I remember that my sine graph starts on the midline, above the midline, on the midline, below the midline, on the midline, okay? And so that is my sine graph. I'll do a dash. It's not my actual graph. Okay, and so that right there is y equals sine of x. Now, notice that if I'm on the midline, my y value is 0. Sine of x is equal to 0. So if I do cosecant of x is equal to 1 over sine of x, so cosecant of 0 degrees is 1 over sine of 0 degrees, and according to this, sine of 0 degrees is 0. So that's 1 over 0. Well, can't divide by 0. So what happens is on our graph at that point, we have a vertical asymptote. So you have an asymptote that occurs because you cannot divide by 0. It just can't be done. Now at pi over 2, sine of pi over 2 is at a height of 1. 1 over 1 is still 1. So that's on that. Now I'm back to the midline. So on the midline, you have vertical asymptotes. Off the midline, it stays that point. And then on the midline, I have another vertical asymptote. So I have 3 vertical asymptotes on this interval from 0 to 2 pi. Then, if you do your inverse 1 over, what happens is this flips up. This curve goes up like this, and this curve goes up like this. And here that your local minimum of your sine graph becomes a local maximum of your cosecant graph. And that right there is 1 full period of this cosecant graph. So in the green, I have our cosecant graph. So notice my sine graph determined what my cosecant graph looks like. And so that's going to happen throughout. So all we're going to do is we're going to change cosecant to sine, figure out the transformations of sine, graph the sine function, and then at the end, do what I did here. Any points on the midline turn into asymptotes. The maximum points becomes the minimum of one part of the curve, and the minimum of the sine graph becomes the maximum point of the other curve flipped down. So, summary. For our sine graph, remember our period was 2 pi, and that translates for a cosecant graph. Our amplitude is 1 in this graph, but remember definition of amplitude. Amplitude is the distance from the midline to the max or min. Well, this graph continues. Our cosecant graph has no maximum because the arrows mean it goes up forever, and it has no minimum because the arrows mean it goes down forever. So technically, we do not have an amplitude. So when I have you list these over here, you'll see that I will put it in parentheses here, in quotations. Okay, the reason I'm putting in quotation is you're actually finding the amplitude of your sine graph or your cosine graph, depending on which trig function it is. And that's just going to tell you, basically that's telling us how our distance from the two curves, half of the distance from between the two curves, the height, the maximum, minimum there. So it's basically, you're finding basically the amplitude of your sine graph so that you can sketch how far apart your curves need to be when you draw it. But technically, there is no amplitude for cosecant or secant. And so that's the reason why I have you put it in parentheses, in quotations. I said parentheses again, in quotations, because it is just a tool to help you graph, but not the actual value. Likewise, our midline is a midline. We have a midline for our sine graph. We have a midline for our sine graph, but we do not have a midline for our secant graph or cosecant graph, because again, midline is halfway between your maximum and minimums, but secant and cosecant graphs have no maximum, have no minimum, so that cannot be. So again, I'll have you identify those for your associated or corresponding function in a sine or cosine, and so I'll put it in quotes when you do it, because there's technically not one. So all we have that we need for our graph to identify key characteristics of our cosecant graph is our period, of course. It took us 2 pi to see this. And then you need to do the equation of your asymptote. So what you do is you find the first asymptote that is not negative. So in this case, at 0 here, at this x equals 0, that's my first asymptote that's not negative. And then you find the distance from that asymptote to the next asymptote. And so I see that has a distance of pi. And notice that I repeat it every pi, I will have another one. So what I say is, okay, my equation of my asymptotes is x equals my first asymptote, which is 0, so I'm not going to write it this time. Usually if it's not 0, you'll write that, plus how often my asymptotes repeat. So they repeat every pi. And then how I say every pi is I say, okay, n times pi, where n is just some integer. Okay, so it's not a fraction of n, it's just n. Pi, 2 pi, 3 pi, 4 pi. So I see it, and if it could, n could be negative. So I know at negative pi, I will have to have an asymptote. At negative 2 pi, I will have to have an asymptote. Okay, so it repeats every pi. So that's how you would figure out your asymptote, equation of the asymptote. Now the domain is also a little challenging because it's all real numbers except for everywhere I have those asymptotes. And everywhere I have those asymptotes are looking at these equation my asymptotes. So for our domain, we'll say all, that's our symbol for all, real numbers, where x is not equal to, and then just copy down your equation of your asymptotes. So it's wherever we don't have asymptotes is our domain. Range is the green, so now I'm looking at the green graph. So it goes down forever up until I get to that value of -1. So negative infinity to -1, including the -1. And then that gives me the bottom curve. And now I need to talk about this top curve. Well, so I do union, and then the top curve starts at a y value of 1 and goes up for forever, for infinity. So that would be our range of this function. Okay. So now I'm going to look at our secant. And so remember, 1 over cosine of x is equal to secant of x. So I'm going to start by graphing my cosine x graph. Okay, so cosine, I have a midline on the x-axis. It starts above the midline, on the midline, below the midline, on the midline, above the midline. Okay, so that, put it in dash, there is my cosine graph. Now, in green, I'm going to do my secant graph. Everywhere I'm on the midline becomes an asymptote because that becomes 1 over 0, which is undefined. And every point that's not on the we flip up, we reflect it. And this right here represents one full period of the secant graph. So the secant graph also has a period of 2 pi. And just like with cosecant, our cosine graph has an amplitude of 1, but our secant graph has no amplitude. And we have a midline of y equals 0, but for our secant graph, there is no midline. Again, I'll put it in quotations so that you'll identify those for your sine graph or cosine graph to help you sketch it. So now I got to figure out my equation and my asymptote. So my first non-zero asymptote is 2 pi. All right, and then how far does it take me to get from this asymptote to this asymptote? Well, I could see that as pi, but if you can't see that, you take your ending asymptote minus your beginning asymptote. I get 2 pi over 2, which is just pi. So it takes me a distance of pi. So I need to add integer times pi, because it happens every time. And these are vertical lines, so it's x equals. Okay. So that would be our equation of our asymptote. And so our domain will be all real numbers, such that x is not equal to everywhere we have asymptotes. Okay. Our range, we kind of look at this bottom curve here to help us figure out our range value. And so it goes down to negative infinity, it goes down forever. And then it stops at a height of -1, including the -1. And then our top pieces here start at 1. It doesn't matter which one you look at. They have the same range. They start at 1 and go up to infinity. So that would be our range. Yes. So, basic summary of this information that we just gone over is that to graph the cosecant function, you will first transform the sine function. So we'll graph the sine function. Then we'll convert the sine graph. We'll convert the sine graph into cosecant graph doing the following way. Everywhere that our sine graph intersects the x-axis or the midline, in this case it was x-axis, but every time it intersects the midline, we will draw an asymptote. And every maximum of the sine graph becomes a local minimum of the cosecant graph. And every minimum of the sine graph becomes a local maximum of the cosecant graph. And then we do the same thing, but for secant, we compare it to the cosine function and do the same thing. So again, if you can graph sine and cosine, you will be able to graph any secant or cosecant function. All right, so let's just rewrite this in transformation form. Okay, so this 1 goes over here. So I have -1/2 cosecant. Okay, I have multiplying by 2, so I'm going to take that 2 out. And when I divide by 2 here, I got to divide this pi over 2 by 2. So that becomes a pi over 4. And then remember I moved that +1 over. So this is the graph I'm actually doing when it's written in transformation form. So I'm going to start, and I'll start this in the green. I'm going to graph y equals -1/2 inverse. The reciprocal function for cosecant is sine. So this is the function I'm actually going to graph first. Okay, so looking at here, I know my period. So remember, period is 2 pi divided by b, which is 2. So that's going to be pi. So the period of pi. Amplitude, notice I have in print and quotations here because this is just the amplitude of the sine graph, which is 1/2. The midline, well, I went up 1, so my midline is now moved up to y equals 1. Phase shift, I have a plus pi over 4, so that tells us I need to go to the left pi over 4. Vertical shift, that plus 1 again, that means I'm up 1. Reflection, yes, I have a minus in front of A, so that means across the midline. All right, we'll deal with the amplitude, the domain range later. The count by I could do, so we're going to take my period and divide by 4. So it's just pi over 4. So on my scale here, I'm going to have pi over 4, pi over 2, 3 pi over 4, and pi. All right, and then I'm going to just count by ones. It should still all fit. Whoops. Okay. All right, so start by graphing my sine function. So this is where this work graph comes in so handy. So my midline is moved up to 1. I'll put my midline in at 1. Okay. I have a amplitude of 1/2. So I've dealt with the midline and up 1. So that's been taken care of. And I've dealt with my period by how I labeled my x-axis. All right, so now I need to figure out, okay, I got an amplitude of 1/2 and a reflection across the midline. I'm going to say phase shift for last, so I'm just going to do those two. So sine graph usually starts on the midline, so what's on the midline stays on the midline. So start on midline, and then I go up my amplitude, so up 1/2, on the midline, below the midline, and on the midline. Now, that's just dealing with my amplitude. But if I want to deal with a reflection, instead of going up like I just did here, let's go down. And then on the midline, above the inline, and on the midline. So now I've dealt with my amplitude and my reflection. And I get a graph that looks like this. And there's one period of that sine graph. Okay, now I have a phase shift left pi over 4. I'm going to do a little darker. Let's do another color, different color. Okay, so now I'm going to move each of these points left pi over 4. Well, that's nice. I'm counting by pi over 4. So each of these dots just move to the left pi over 4. And this is now my sine function. So this is my sine function dealing with all the transformations. Okay, so I got all the transformation of the sine function. So to get my final graph, I'm going to go down here. All right, so what I do is I would start by graphing my midline. Now again, remember midline's in parentheses. Technically I don't have a midline, but it gives me something to help me kind of what I'm going to graph on this. Okay, and then notice that the blue graph above, I'm just going to put the dots. I'm going to connect lines. At negative pi over 4, I'm on the midline. Then I'm half below, on, half above, on, half below. Okay, now let's repeat because we need to go to another period over here. So I was below, so now I need to be above, on, below, and then back on to get a full over for 2 periods. Okay, everywhere I'm on the midline, I'm going to do in purple the actual graph. Everywhere I'm on the midline is an asymptote of my graph. I'm just going to draw asymptotes there. Everywhere that I'm on the midline. And then I'm going to do from each dot, approach the asymptotes, never crossing that midline. So go in the opposite direction of the midline for each of these. That's the reflection over, or the 1 over, the reciprocal identity does that. And that is 2 full periods of my cosecant, this original function here. So I've now graphed that original function. So notice sine is how I did it. So all I've got to do now is figure out my asymptote's domain and range. So my first positive asymptote is here at pi over 4. And I've gone from pi over 4 to 3 pi over 4 is the distance I've traveled. So 3 pi over 4 minus pi over 4 gives me 2 pi over 4, which is pi over 2. So I'm going to add n times pi over 2. Okay. And so that is the equation of my asymptote. X equals that value. And that's how you figure out your asymptote. Now my domain is all real numbers as long as it's not an asymptote. So where x is not equal to my asymptotes, where I have an asymptote. Okay, range, negative infinity to my local maximum, which is at a height of 1/2. Okay, including that, up to my local minimum, which is at 3/2 to infinity. And now you have completed the graph of this cosecant. So let's do one more. Let's graph a secant function. I got started with blue. Okay, so first I need to write this in transformation form. So I need to factor that 1/2 out. And when I factor the 1/2 out, and dealing with that 1/3, that negative 1/3, I get negative 2 pi over 3. Because 1/2 times 2 pi, the 2's cancel out and I get pi over 3. Okay, and then I still have minus 1. So in green, I'm going to graph y equals 2 cosine of 1/2 x minus 2 pi over 3 minus 1 to help me graph this. So I need to figure out the period of this. So period is 2 pi divided by b, which in this case, that would be 4 pi. So I'm going to be counting by 4 pi divided by 4, which is pi. So on my scale over here, each tick mark is going to be pi. All right. My amplitude is by A, so that's 2. Again, it's in quotations. Let's go back to green. 2 is in quotation because it's not exactly that. And so I've gone down 1. So my midline is at y equals negative 1. Now you can change your scale on this one if you want. I'm going to stick with 1. It goes a little bit off on my final graph. So if you want to change your scale, you could count by 2s if you wanted to. But I'll just extend out. It'll be fine. All right, so, whoops. And so we have a midline at negative 1. Okay, let's see. Ooh, our phase shift is 2 pi over 3 to the right. Okay. Our vertical shift is down 1. There's no reflection. Okay. So, I've already dealt with period by changing my scale. I don't have a reflection, so I don't have to worry about that. I've already moved my midline down, so I've moved my down 1. So now I just need to do my amplitude and my phase shift. Okay, again, you can do these separately or together. Since I did them separate last time, I'm going to put them together this time. So normally, my cosine graph would start above the midline by an amplitude of 2. So that's where my graph would usually go. But I need to take that and move it to the right 2/3 pi. Well, that works out perfectly. 1, 2, 3 tick marks gives us pi. So I just need to move that over to 2 tick marks. So that point becomes here. Okay. So that's how I'm going to do it. So I'm just kind of moving each of these over. So then I'm on the midline move that over 2/3. Okay, then I'm below the midline by my amplitude of 2, move that over by 2/3, put this here. Okay. And then I'm back on the midline, move it over by 2/3. And then I'm above the midline, move it over by 2/3. Okay, and that gives us 1 period of this cosine graph, the associated cosine graph. So to graph my actual graph, I'll do that in purple. Okay, so I have, there's a dot. I'm going to do my midline to help me out, although the graph again does not have a midline. Okay, and there's a dot. And one period. Let's do another period back. So we're above, so when I'm going backwards, I now need to be on the midline. Okay, below the midline by amplitude, on the midline, and then above the midline by the amplitude. Okay, everywhere I'm on that midline, the reason why it's important you draw the midline is I have an asymptote. So I'll put in my asymptotes. Where I'm above the midline, we go up toward our, oops, that did not go well. We go up toward our asymptotes. Okay, everywhere below the midline, we go down toward our asymptotes. And that is the sketch of this secant graph. Okay, notice that the bigger midline stretches those out from each other. All right, so to find our equation of our asymptote, we find our first non-zero asymptote, which would be this one here. So I need to figure out what that is. So this is pi plus, so that's 3 pi over 3, 4 pi over 3, 5 pi over 3. So that gives us that 5 pi over 3 is our first non-negative asymptote. And then, how long did it take us to get to our next asymptote? Well, that's exactly 2 pi. So it took us 2 pi. So 2 in pi, because we got to multiply by integer, or n is some integer. Okay, so that's our asymptotes. Now, if you don't want to write this n as some integer at the very beginning, just write at the very top of your work, n is an element of the integers. N as always just represents an integer. All right, domain. Okay, so x values everywhere except where our asymptotes are. So that's going to be all real numbers, such that x is not equal to 5 pi over 3 plus 2 in pi. Our range will start, I'm going to look at this one down here. You need to pick any one of the curves going down. So that starts at negative infinity, and it goes all the way up to a height of negative 3, including the negative 3. And then pick one of these that goes up. So I'll look at this one. Okay, and then that starts at a height of 2, and it goes up forever. There's our range. And that's how you graph secant and cosecant graphs.